right.
Well, welcome to the August 10th, 2021 session of TangerineSDR and HAMSci technical sessions. My name is Dave, KV0S, and this week I actually did a little programming project suggested by Scotty, so I can talk about that a little later. Next, the programming project is one that can take comments and code and build a markdown README file. So anyway, next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks a lot, Dave. Last week, we finished up our summer research program for the students. So they get a little hiatus for a couple weeks, and I get a little hiatus or change now as well. But we're still working on things. So let's see. So I'm working on my LSTID paper. We had a barbecue where the students came over to my house to wrap up the summer. And now we're getting ready for a TAPR DCC. So I guess when we get to the open session, I have a list of proposed talks that people from HAMSci and the TangerineSDR project and magnetometer project will be want to give. So maybe we can all look at that together and make sure we're happy with it and make any suggested changes. So W2NAF, back to Nat.
Well, fine business. Next on the list, we have Bill N8ET. Go ahead, Bill.
Yeah, I was busy doing other things this week away from home, so I'm here just to listen tonight. So back over to you.
Okay, fine business. And next is Bill AB4EJ. Go ahead, Bill.
Thanks, Dave. Well, this week was devoted to, I went through and reran all the RF exposure tests on the magnetometer so that I could be very careful to collect data suitable for publication at the DCC. I'm going to give a talk about that and write a paper about it. And I found out, okay, here's what I found out. There are a lot of situations where you can see a little bit of RF in the magnetometer data if you use a very sensitive test. The test that I've been doing works as follows. It's a 3-minute test. I collect data just on background. Well, this is done for all bands 160 through 2 meters, done with carrier, CW, and sideband, done with both magnetometers so I can compare the results between the two. Magnetometers are different places in the yard. And in each case, I have a 3-minute test. I collect data on background with no RF for 1 minute. Then I turn the transmitter on for 1 minute, then turn the transmitter off and collect data for another minute. So that gives me a before and after background. Then I take the background before and after, I combine those two and get a population of the magnetometer reading. And then I do a two-tailed t-test on that to see if the results during the RF are significantly different, 5% confidence. And I found out that there's, because that's a pretty sensitive test. So I found out, yeah, you can move the magnetometer readings with RF in a lot of cases. Now, the movement of the data is so small that you can't see it with the naked eye. If you take and you plot that data, you're hard pressed to see that there's any impact. Okay, so what I've done is I'm going through and figuring out what the mean differences are and then taking that back to a percentage so that I can say, okay, here's where you see enough of a difference that it could affect your readings. And in most cases, even when you have a significant difference from having RF, it's still small enough that would it really affect your overall readings? Probably not. So anyway, I'm going to provide that in a write-up and try not to make people's eyes glaze over with all the statistics. You know, how that can happen. But anyway.
Bill, what are the parameters you were using on the magnetometer when you did that?
Say that again, Jules.
What were the parameters you were running on the magnetometer? What was A and so on and so forth? What how many cycle count?
Pseudo Runmag minus M23 minus A10 minus U140.
Okay, that's typical. Yeah.
Yeah, and so like I said, every time that I saw a different, one of my magnetometers is very close to my dipole, my 80-meter dipole, which is only up at 16 feet. And one of the magnetometers is kind of like right underneath it. And I intentionally kind of said, hey, let's just see what happens. I can actually turn the magnetometer off when I put a kilowatt into that dipole. Okay, but it doesn't get bad readings, it just cuts off. So the I2C power supply or something's getting swamped and it quits working and it starts working again properly and it looks beautiful as soon as you turn the RF off. So that's a special case where you actually kill the functionality of it. In most other cases, if you're looking at a change, it's almost always less than 0.1% as far as an impact from the RF. So you can see it in a very sensitive test like Students T, but as far as I'm gonna provide some plots that show here's what you're looking like, where in the middle there's a chunk of RF being thrown in the magnetometer, and in most cases you don't see it with the naked eye. So, but anyway, that's yeah.
One more comment on that, Bill.
Yeah.
You may have to redo those tests because right now we're discussing the result registers, which really, in order to, especially to take advantage of the low averages like 10, we really need to be saving at least 1 decimal point of precision to the right of the decimal, that is at least 1 or 2 decimal points of precision. And we've been discussing that with Nathaniel and Yeoman and David Wong. So if what that will do is actually improve the resolution and possibly let you see even more of an effect.
Well, I guess, yeah.
I mean,
the
fact that you're seeing something at all is meaningful, and and all you'll see with the t-test is you'll see maybe another couple of tenths of a percent improvement in precision, but that's about it.
Well, with more precision, the most likely outcome is that a number of places where Students T shows no significant difference, the difference might be significant if we get more precision. However, I'm looking at changes in the mean. Going out to more levels of decimal points isn't really going to move the mean very much. So,
right.
Yeah. So
okay.
Anyway,
Yep.
Yeah. Anyway, that's going through and running these tests and doing all the data analysis on all bands 160 through 2 and 3 modes each. It takes a whole day to go through and do the test, and then a whole day to do the analysis. So I hope I don't have to do it again, but if we need to, I can. Anyway, back to Ned.
Well, fine business. And next on the list is Dan in for XWE. Go ahead, Dan.
Thank you, Dave. Hello, everyone. This week I bought an NVMe drive, 500 gigabytes, and I bought a little, can't see much here, but this is what it ended up being. Bought a little USB 3.1 enclosure and card to do a conversion, and hooked that up to my Raspberry Pi. It's kind of a mixed bag because the Pi does run faster. It downloads much faster if you're doing downloads, and probably uploads much faster as well. The downside is the USB, possibly the wireless chip, this dongle, and my mouse and keyboard RF interface are all running simultaneously, and it creates a real problem because the Raspberry Pi just doesn't have enough oomph to manage all of that data moving back and forth through it. So if you take away one of those devices, it seems to work okay. But with all of them in operation, it doesn't work very well at all. Anyway, that's kind of the story from here.
Well, fine business. And next on the list is David in one HAC. Go ahead, David.
Oh, hello, everyone. Big thing this week was not having to do with Tangerine or even professional. It was amateur telescope making, Stellafane amateur telescope making convention was this week, where I'm an active member of the club. And it was actually in person this year, and hopefully no one got sick. We've got 80 acres of land to spread out over, so we're keeping our distance. One thing I will report that is of a radio nature, which was pretty cool, was someone brought up a radio telescope of working with the hydrogen line. It was about a 1.5 foot square horn antenna with made from masonite and aluminum foil, and an RTL SDR dongle and appropriate software. And it they were able to map the arms of the galaxy with this by the Doppler shift, and actually were able to demonstrate that Newtonian gravity does not apply to the rotation of the galaxy. I was quite impressed. And hopefully, as we get aspects of the TangerineSDR going, you know, it shows that it doesn't take very much to be doing real radio astronomy with these radios. So back to net.
Well, very good. Sounds interesting. Next on the list is David Waugh. Is that correct?
That's correct, or certainly
Close.
very close, very close. Good enough. I've ordered supplies to move my magnetometer in the yard, so I'm not gonna use conduit because I'm only going to extend it 30 feet. But Jules helped me figure out the wire I needed, and I'm going to put it in a sprinkler valve box because if it were sticking above ground, the dogs would pull it out, chew it, and cause a general mess like they do with everything else. I've also been working on the summary data for the magnetometer, and I think I've made some progress there. And Jules has been very patient with trying to help me understand how the magnetometer bus works. And I even made some artwork trying to figure that out. That will be auctioned off at Christie's. I think the ham folk art is on the 42nd of each month. So stay tuned for that. And back to Dave.
Fine business. And next on the list is Dave Witten, KD2MR. Go ahead, David.
I remembered it. I don't even have it on my thing. Yes, I've been doing software. I've been trying to do both trying to create a Python-based web server to replace or simplify that local monitoring application, but I have that has turned into a swamp. But on the other hand, Jules and Dave Waugh both have things that they want adjustments to the Runmag program, and Plus, I've had to juggle a whole lot of other things. And the upshot has been I haven't really I don't feel a lot of accomplishment on any of them. So we'll see. I don't know that Bill needs to worry right away about redoing his numbers, because it's going to take me a little while to get him something to redo them with. So we shall see. Even though some of the changes are pretty simple, there's just all sorts of things, and everybody wants me to redo my sign-ins to everything. And but anyway, so that's it for me. Over to you.
Okay. Next on the list is Gary, AF8A.
Yeah, good evening, everyone. It's good to be back. I've been busy moving to a new home in a brand new neighborhood. And hopefully one of these days I'll get the shack put back together and at least I can get up and receiving. One interesting point this group might appreciate is that this neighborhood is brand new and Google Maps doesn't really know where it's at yet. But there's a similarly named street in a similarly named city only a few miles from here, and it keeps sending everybody over to the next city, including the moving van that held my furniture. So I've got to figure out how to tell Google that we exist, but that's my issue with it. I hope to solve relatively soon. But that's it for tonight. Back to Nat.
Well, fine business.
They do respond to emails. I've done that.
Ah, good. Thank you.
Next on the list is Yeoman KD2MR.
Yeah, good evening, everyone. Yeah, just like Gary, I just moved to a new place, so I've been pretty occupied with moving, which is endless, unpacking, boxing. Otherwise, I don't have anything to report this week. I think that's it. I'm looking forward to discussing the presentation that Nathaniel suggested. So otherwise, I have nothing to report. So back to Nat.
Okay, next on the list we have James KG4DSG. Go ahead, James.
Good evening, all. Not much to add here. I did have two questions. I don't need an immediate answer. Maybe Scotty can answer it later. The second revision FPGA that they're talking about, and I know that's not set in stone, but does that have any effect on the development software? I know some FPGA providers, when you step up on the products, you have to go up to the higher end development tools. And if somebody could address that later, that's fine. And the other question I had was for Dan and his Pi problem. How are you powering that Pi?
I'm powering it with the official Raspberry Pi power supply. Okay,
it may be a little weak.
It may be, but I'm actually I looked at the power pass through and it's less than 2 amps, so it should be good.
Yeah, I know there's a problem with power draw when you really start to load the peripherals down on that thing.
Yeah. Yeah, I forgot to add, I actually was using an RTL SDR dongle with it as well. It didn't help things out very much, believe me.
Okay. I would look at power first, but it sounds like you may have already looked there. So with that, back to the net.
Okay, next on the list, we have JWB8SBI. Go ahead, Jay.
Hi there, guys.
There you go.
Yeah, let me turn on the video microphone here, as we used to say. Hopefully, there it is. Hi there, everybody. Yeah, I've been away for a while. Not a whole heck of a lot to report here. Been very, very busy with a project from a cybersecurity project from the Society of Automotive Engineers. So that's been taking up a lot of my free time. But hopefully, I'm going to try and work some time in to get back to this project, which I really want to do. So other than that, I think the online, the QSO, the International ham online QSO thing is this weekend, if I remember correctly, and or it's coming up. So anyway, other than that, nothing new to report here. Take care, everybody. Stay safe.
Fine business. And next on the list is Joe W7LUX. Go ahead, Joe.
Thank you, Dave, and very good evening to everybody. Well, the grape receiver is still chugging along and monitoring WWV 10 megahertz. I've got a MAX10 set up with the what is it, Cordis software all installed on one of the computers here. And I'm still having a lot of trouble getting my radio to work properly on ancient modulation to run some tests with Steve. So that's kind of a problem working with Elcraft on that one, and they've suggested maybe there's a problem with filters, so I got another filter on order. Meanwhile, we've been doing public service events. A friend had some medical issues, so got tied up there, and been working on portable equipment. I coordinate ARAS in this area, and we have a need for portable stations. We have a number of athletic events that run from Flagstaff up to the Grand Canyon, and we need portable setups there. But one question, that hydrogen alpha line receiver that, I forget now who was talking about.
David.
David? Okay, David, how large was the antenna for that that receiver?
Yeah, it's about 1.5 feet on a side, 0.5 meter.
Okay, that was what, a patch antenna?
That was a horn.
A horn. Okay, okay, horn. That's good size horn. Okay, thank you, Dave.
Yep.
Next on the list we have Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I've been I finally figured out the issue with my ELF preamp. It was the 9-volt batteries that I'm using. They were discharged a little bit, and even though that the voltage was within the range of the input, the batteries could not source enough current to keep the regulator going under load, because the first regulator, the source regulator that's inside the test box, or the DC to DC converter, that needs about 20 milliamps of current to operate. It's quiescent current, and the batteries were probably discharged about 40%, and it just wasn't enough to supply the current. When I powered it with a DC adapter, everything worked perfectly. So I had taken apart the circuit of my VLF preamp, but I was able to put everything back together. I even fit a new DC to DC converter in such a way that it does not hit the inside the inside of the PVC pipe. It actually fits better than the old one did. I also got 12-volt input DC to DC converters for the test box and the Raspberry Pi box to match the power adapter and battery input. Even though that didn't matter, that was Paul's recommendation. So I have to put everything back in the pipe. I'm going to do a quick current measurement to see exactly how much is drawn from the batteries and the power adapter, and I'll probably test it sometime tomorrow after work. Also, one last thing, a comment about the Raspberry Pi. Paul Nicholson with his Raspberry Pi VLF SDR, he ran it into the same issues that the Raspberry Pi would actually reboot during moments of high load and high current draw. And he's been using a 3 amp DC-DC converter, an LM 26 LM. I forget what it was, but you could find them on Amazon. They're adjustable, and they work really well. And he's been using them, and he hasn't had any reboots of the Pi, and it's also driving a sound card hat as well. And I've been using it, and it's been driving the Pi, a sound card hat, and a Trimble Res SMT 360 timing receiver. So it's been powered with no issue. So I would recommend at least 3 amps for the Raspberry Pi, and you shouldn't have any issues. That's all I have. Back to the net.
Fine business. And
if I could add to that, some of our personal experience on that while we're talking RPi's rebooting. We found that hard drives, if you're running external hard drives, they may not run reliably off of the RPi directly. You have to power them separately, because even a solid state drive, even though it may run very low power average, it can have over an amp peak, which will take down the Raspberry Pi's USB port. So you need a lot of power for some of these systems.
fine business. Next on the list, we have Jules K2KGJ. Go ahead, Jules.
Okay. One thing to Bill, if we have time and we do any rerun, I would suggest picking the one that shows the least sensitivity to the RF to redo if we do anything at all. But I wouldn't suggest anything more than that. But that depends upon when we get the modifications to Runmag. Regarding that, this week I was working with David Walk, and we've been comparing some readings with Runmag and also with my Python code, which I use on my dual magnetometer setup. And that one, I'm saving up to 2 decimal points of precision after applying the gain correction factor at the end of each collection cycle. And in comparing that on a run the same day, I think it was August 5th, I did it with Runmag and the other installation that I have. There was a very, very significant difference in not the 1 minute running average, but in just the straight average product as it comes out with, which at the moment does not have, is integer truncation in Runmag, and in my system up to 2 decimal points of precision. Graphically, it is very, very apparent that just an additional decimal point would make a significant difference in resolution and signal to noise ratio. There's also some evidence that increasing the cycle count above 400, maybe to 600, 700, may actually have good results, even though the basic literature from PNI suggests that it gets noisier at that point. I'm not exactly showing that same result. The other interesting piece is in doing this that the NOS register, which we use for averaging, was actually a feature that apparently was originally used in engineering development for the product and is not generally documented in any of the literature you find on the PNI. In fact, it was the person I spoke with at PNI considered that, well, not a terribly useful feature, but in fact, in using it, you save substantial time in the number of averages as opposed to doing one command, waiting for that to complete, sending a second command, and so on and so forth to get the same number of separate readings including the problem you have in storing those intermediate results on your local computer. So it turns out that that averaging feature in the NOS register is very, very valuable, which we kind of discovered by accident. That's about all here. Also, David, in terms of, Dave Whitten, in terms of any changes, yeah, we've been discussing some timing issues and so on too, but the major change that would significantly improve our ability to collect good data is to just add even 1 decimal point of precision to those when you do the gain correction at the end of the run of each run. If we could add that in, that would be the most significant thing I could think of at this time. The other stuff we can talk about later, but if you can do that at some point and, you know, ignore the other stuff right now, that would be the really significant change. With that, back to Nat.
Well, fine business. And next on the list is Con. Go ahead, Con. Are you there? Oh, there you are. Mike?
Are you talking to me, Contran?
Yeah, I'm
okay,
sorry, I
sorry.
pronounced it wrong.
Okay, hey guys. I'm just still busy programming. I got some the app, produced some good visuals. I still got a lot to do, but yeah, I'm just still banging on the keyboard for now. But once I get something that's pretty cool to look at, I'll send the link over. But yeah, that's it for now.
Okay. Next on the list, I'm gonna jump to the bottom because we have a new person, or at least not a regular, Willie Smith, N1 JBJ. Go ahead, Willie.
Bill, mostly just watching. I built up Grape 1 last week and gathering some data, but I don't know if it's any good.
Well, if you find this useful, please keep coming.
I'm hoping to learn some stuff.
Very good.
And I just remembered that the Raspberry Pi also flickers its power light when it gets low voltage.
Yes.
So you can watch that. One question about the magnetometer, although I'm not there yet. I have a well in the middle of my backyard, and there's a well casing that goes down a couple hundred feet. Is that going to affect the magnetometer? Do I want to be far from that? If I
Let's ask Jules that question.
Sorry, I missed that. I was speaking with my wife. Our youngest son had a biking accident earlier today, and I was just getting an update. He's coming back from the hospital after surgery. So, what was the question?
Oh, sorry. I've got a well casing in my backyard that's 6 inches. It's a 6-inch steel pipe that goes down a couple hundred feet. If I were to do the magnetometer thing, do I need to keep it some distance from that?
Yeah, that's going to cause some distortion. I'd ask Yeoman what he thinks, but I would say at least 30 feet. Yeoman?
What do you, like steel pipe is that?
Yes.
Yeah, it's a 6-inch steel pipe.
The well casing.
It's a well casing, so it goes from the surface vertically down below the water table.
Yeah, I mean, general rule is to avoid any kind of metallic magnetic material nearby, but things are all relative. You know, we haven't really tested like how our magnetometer is affected by, you know, magnetic material around it. So yeah, I don't know. I would say just as far as possible, but I cannot really have a number or yeah, everything is relative. So, but 30, did you say 30 feet?
I was suggesting 30 feet. It will, no matter if you're within probably 50, you'll get maybe some distortion of the field, but in terms of what we're looking for, ultimately, probably not going to be much of a problem. But if you get any closer than that, it may be an issue.
The other question I had is, where is the pump? Is it above ground or is it submersible?
No, it's submersible. It's down 600 feet. So yeah, there's some big wires running down. Hopefully the currents are balanced.
Yes. Well, the AC lines that are running down there, those are fairly close together in the external field, especially with the shielding of the steel well casing isn't going to be a problem.
Yeah.
It may be wherever it runs underground to get into your house to the well pump breaker or whatever. You might want to stay away from that, but other than
Yeah,
that,
that's coming back towards the house. So
Yeah,
I mean,
okay.
I could put some extra conduit out to the well casing fairly easily to do radio stuff, or put the magnetometer over there, or something along those lines. So.
Okay.
And one advantage to a well, and I'm a geologist, so I'm qualified to say this, it's not going to move.
No.
Yes.
So, keeping it away from cars might be in some way, I mean, yeah, the well is certainly going to have an effect, and I'm not qualified to talk about the magnetometer in general, but cars will have the well will at least be static. Whereas if it's closer to 30 feet to cars, that will cause more issues and things that I'm looking at.
Yeah.
All right. So yeah, there's the neighbor's house is also sort of in the backyard, so their parking is over there, and then the other neighbor has a pool, so they probably have pool equipment. So
Sounds a bit like David's backyard.
have to see what I can come up with. But so I'm gathering data, and I'm sort of testing antennas and trying to figure that kind of thing out. Is there something I need to do to get a node number to start feeding the data into some data gathering process, which will tell me if it's any good?
You need to get that from John Gibbons, who's, I don't believe he's here tonight. He doesn't usually participate in this, but he's the person who hands those out. And I suspect the information relative to that is on the HAMSI website, and wherever you found the software and things that you've gotten so far. I'm pretty sure, but he issues those node ID numbers.
Yeah, John always shows up to the Thursday morning telecons, and yeah, he will give you the node number, and we're still working on the central collection point for that, but they are working on that.
Dave Whitten, your mic is open.
Is there any way to know if the data that I'm gathering is any good? I'm trying different antennas, I'm trying different orientations, I'm powering the GPSDO from the Raspberry Pi or from a battery, these kinds of things. Is there a quality metric I can easily pull out of the data?
We're still working on developing a quality metric right now. That's one of the discussions we've had at the last couple of Thursday morning telecons. I can tell you that if your signal to noise ratio level, the red line, is probably -30 or higher, it's probably okay. Also, you're going to see a large transition in the Doppler shift frequency as you go from dawn to dusk. So those are some good indications. But we are still working on developing an actual quantitative metric for that.
Cool. Anyway, I'll go back to listening.
Thanks.
Okay. Next on the list is Michael, AAK. Go ahead, Michael.
Well, thank you, Dave. Greetings to everyone listening. I'm surprised that casing is that long. Often it's only near the surface and doesn't run the full depth of the well. An interesting.
No, the well's 600 feet deep, and the casing goes down into the bedrock, and then it's
a deep well.
We had it hydrofracked below that, so we could actually get some water.
Excellent.
It was an easy task. No, we didn't.
Don't they often drive that down? Isn't that creating a magnetic field when they hammer that down?
Well, there's a lot of iron in the water. So as the iron laden water is moving around, you're going to be able to track
Thanks, gentlemen.
Yes.
Back
Measure
to
the
you, Dave.
water table, right?
So next on the list, we have Scotty, WA2 DFI. Go ahead, Scotty.
Oh, okay. Can you hear me now?
Yes.
Yes. Okay. Not a lot going on this week on the nothing on the data engine, of course, because we're still waiting. But one of the things, Jonathan, we got your A to D converters in, the 10 A to Ds that we ordered on back order. They were not supposed to be here till September, end of September, I think, and they just arrived today. So for the VLF receiver, we have the chips. We have 10 of them ready to, excuse me, ready to go. Also been working on some clock module support for John Ackerman. He's built an evaluation board that will that uses the same topology as the clock module does. And we've already got the evaluation boards built, which have the clock oscillator and the jitter reducer part on it. And he's got the GPS version, a version that just holds the GPS. And so by using those two boards plus the evaluation module from Silicon Labs, he can actually lash up an exact copy of what our clock chain looks like on the clock module. He's going to do some measurements, and he's got a brand new whiz bang. I think it's a phase noise measurement system that he won't even tell me how much it costs because it's a lot. So so to give you an idea, he said his wife got a new kitchen and he got this analyzer. So you can tell his priorities are in the right spot, but you can tell it's probably a lot of money. So anyway, he's all psyched to use that and evaluate our clock chain. And so I'm trying to get that done. We switched oscillators in midstream. We went from the Raycon oscillator, which we could not get, to we had some samples of the 40 megahertz ones, but we really needed something in the 50 megahertz range. And Raycon said they couldn't do it. So we ended up going to a better oscillator, actually, more expensive, unfortunately, but a better oscillator in the Vectron name, which is microchip. And I've got those. They came in a week or two ago. So now I'm in the process of getting the board modified, reworked to use the new oscillators, so that he can have the proper oscillator in the chain and the right frequency. And then the other problem he has is that the GPSs, of course, if you've seen the clock module, the GPSs has a grid of pads that are underneath the GPS that it solders down to, which means you can't just use a soldering iron to solder it down to the board. So he's going to send those boards down, and we're going to have our CM down here with his hot air machine assemble the GPSs onto the board. So it's a ZF9 T, I think, is the one he's going to use. The same one we're going to use on the clock module. So I'm trying to get that all squared away and ready to go. And then the other thing we've been doing is the magnetometer. The production version of the magnetometer is it's in process right now. I ordered the boards. It's a 3-week turn, but that's including assembly. So we're having a race here to see whether we can get the parts in time to not hold up the build. But within 2 or 3 weeks, we're going to have production magnetometers. So we'll be able to send those out to Dave Witten and let him do his 3D printing magic on the brackets. And then we'll be ready to, pretty much after those are tested, we'll be ready to go into production on the kit anyway, the board kit. So we're really need to work a little bit following up in the next few weeks on the in-ground kit, how we're going to do that, what parts we're going to use and all that. So I think that's about it for over here. So back to you, Dave.
Fine business. Scotty, were you here when I mentioned that I got the little program that you asked for done that reads the comments out of a Go, C, C++, or Verilog file and turns it into a markdown?
Oh, okay. So you want me to send you a file to test it out
on? Sure.
Okay. That reminds me, was it, who was it that had the question on the tools? I think that was
it was me.
Yeah. Yes, you're exactly right. When we go to an ARIA 10, the tools are not free anymore. You have to buy a megabuck, well, a kilobuck anyway, tool to be able to compile it. So we're trying to work out some way to do that. I think ORI has got got a Xilinx license as a network license. And so I think we're going to try to work with the ARDC and get maybe 1 or 2 network licenses, and ORI has agreed to put them up on their server. So we would be able to check out, FPGA developers would be able to check out a license, and we could have up to 2 people running at the same time. And realistically, you only need the license to compile. So you can do your engineering, your editing, your design work and all that. And then when you're ready to compile it and try it out, then you get to check out the license, you compile it, and then you check the license back in again. So really 1 or 2 licenses is probably going to be sufficient for, a group of 4 or 5 guys working on it. So that's kind of where we're headed with that. So hopefully we can get that taken care of, because that's a big showstopper for that FPGA if you can't do the compile. The other alternative we could do is, if we have some people on here like me who have full paid tools, send me your code, I'll compile it, send you back the compilation. But that's excruciatingly slow in terms of a turnaround for testing fixes and updating and things like that. So much rather have a network license that anybody in the group can just check out.
We'd have to send it out on punch cards, right?
Yes.
Yeah, that's right. And you have to send it by mule.
I was going to say Greyhound.
Yeah.
So are you done, Scotty?
Yeah, I'm done. Thanks, Dave.
Next on the list, we have Tom, and Tom's been active this week. Go ahead, Tom.
Oh, good evening to everybody. I started working on the MAX10 development board, FPGA code. I got the NIOS processor built and running in 4K of on-chip RAM, and hello world written in C, and it prints out through the JTAG UART on the development board to the terminal. I then built a gigabit Ethernet interface to the DMA controllers, the NIOS 2 processor, and 32K of on-chip RAM. Got that connected up error-free and attempted to synthesize it, but the synthesis fails because the Ethernet interface IP from Altera is not free. It requires a license to use it. And so I think the word dead in the water kind of comes to mind here.
Yeah.
And so I sent Scotty and Nathaniel and Dave an email about it. We have a couple of options here. One option is to license that IP. The IP is the quickest, easiest way to get the gigabit Ethernet interface into the code stream. There are some open source packages I found. One on GitHub that's in Verilog, one that's on opencores.org that's in VHDL, and another one that's in Verilog from OpenCores. I got my OpenCores registration completed, and I've got that done. The difficulty with the open source is that all the interfaces are incompatible with the Altera Quartus tools. And so the macro that they provide has Avalon bus interfaces for streaming data, for the memory management and control. None of those exist on any of the open source. And so we would have to customize the Verilog in order to work with all the other modules in the FPGA. And so I think as a team, we need to decide whether we should license the IP for the Ethernet module, or if we should find a skilled FPGA developer and try to figure out how to bundle all the open source stuff into a macro that works. I thought about an architecture for the FPGA code. I think I have some ideas that might work that would make most of the development in C and less of the development in VHDL, at least for the UDP and for ARP and DHCP and for the data engine protocol. so we can get all of that into C. Of course, still requires VHDL for streaming the data, since that's the high-speed stuff. So I think we have some hard thinking to do here pretty quickly. So back to Nat.
Fine business. I'm amazed at the amount of productivity you've had this week. It seems frustrating, but you've done a great job for what the task is.
Yes, definitely. And I think that just escalates our desire to get a license for all of the IP and get it up on the server, get it up on a server somewhere.
Yeah, the IP for the macros is different than the IP for the tools, and that it looks like it's a single developer seat license. In some reading, it looks like the macro license has a limited time on it, and that I can't tell by reading it whether you can't compile it after a certain date, or whether you can't download it to the destination target after a certain date. If it's the latter kind of license, it's a really bad deal.
So you're talking about if you license the IP separately.
Yeah.
Right.
Right.
The way it normally works is that what we would do is we would get a full seat license, and then we would add the packages that include the IP that we want, which would be basically all of them.
Right.
And then all of them would be just included in Quartus, and you just compile them with impunity if you had the license. So when you'd log in and check out the license, and then you could use anything you wanted.
Yeah. So in trying to do it separately, I was a little confused. The Intel website had mostly dead links to the Ethernet MAC license.
Well,
And
typically,
so,
what would happen is you can evaluate it. I don't know if you have to pay for that, but if you get an evaluation copy, it will run as long as you're plugged onto your eval board, as long as Quartus is plugged onto the eval board. So that becomes a way to evaluate the tool, the IP, without actually having to pay full boat for it. Because,
right.
but then you can't ship anything like that, because as soon as you unplug the Quartus, the byte blaster, then it stops working.
Right. So I sent you all the error messages. I'm getting the error message says that it's a time limited trial, and apparently I installed Quartus long enough ago that it's timed out, and it told me it's timed out and I can't use it.
So what did you get, 30 days or 10 days or what?
I installed Quartus probably about 20 days ago, but it was from a download that I downloaded a year ago. And whatever it is, I can't use it because I'm timed out, and I never ever got any valid time on the license.
Okay.
But the IP for the Ethernet MAC appears to be totally different than the Quartus tools IP. And one statement in there concerned me. It said that you can't download it to a target after your 1 year is up. And if that's true, then the project would have a really hard time using the IP, because a year from now, nobody could program their device. I don't know if that's true or not. But in my view, we need to investigate what the IP is for the Ethernet MAC. And the only instructions on the website are call your sales guy.
Call your sales guy, yeah.
That's you, Scotty. You have to call
give him
him.
your VA, give him your Visa card number, right?
I've got another question.
So a lot of the IP says that there is university programs that get the IP free. And so if that's the case, we may be able to get around this. And so in the email, I asked Scotty and Nathaniel to perhaps take a look at this.
But one thing is true, is that when you license Quartus, you license IP packages like this IP base suite that you mentioned in your email here. That's a special IP package that you add on to Quartus. And once you add that on, then it becomes part of Quartus, and you, in the library functions, you'll see the new functions will appear, and you can use them just like you can use the functions that are included in without any add-ons.
Yeah, the Ethernet MAC shows up as the IP. I was able to instantiate it, wire it up in QSYS, get all the bus errors resolved, get planning done, compute gate counts, synthesize it, and then the error message, you need a license if you want to make it real. And it was not known until that point in time that a license was needed.
Okay, so it did appear in the directory, the IP directory.
Yes, and I clicked it in, put the blocks in. I got all the blocks on the drawing. It's all there. It knows how big it is. It knows how many gates it is, and it says all the Verilog is encrypted.
Yeah, except you can't load anything. You can't.
Yeah, without the decryption key, I can't do anything.
Right.
Is there a way that Tom could send a file to Scotty? You supposedly have a full license. Could you compile it?
Yes. But then when he wants to make a change, then you got to go through that.
Right. My first step was just to have the NIOS CPU talk to the gigabit Ethernet interface and at least try to get the DELE protocol up enough. The second step then would be to stream data from the receiver so that I could actually test the receiver module. Without that ability, the receiver is not testable.
Got a general FPGA IP question. I know in some instances, and I'm not saying this is one of them, that there's a per device charge when you go to distribute that. Does that apply to any of this?
No.
So you get a license, you can make 1 million of them.
Right.
Well,
okay.
the IP for the macros does not have descriptive terms on the Altera website. What it has is dead links.
Yeah. But generally there's no, I don't know about third party IP, but Altera IP, they don't charge per unit.
Okay, so
once you can load it, you can program it anywhere.
Okay, so I make the plea for help here. I need someone
well, let me see
who the local sales guy is.
Even if I can get you a temporary license that we could use for hopefully more than 3 months, more than 1 month, then that would get you going again. So let me see what I'll talk to our local guy and see what we can figure out.
Okay, I think there seemed to be an indication that universities were exempted from all of this. And so I'd like to ask, maybe Scotty, you and Nathaniel can figure out a solution here that can keep us going.
Well, I know one thing that we used to do back when I had a really friendly FAE is you just call them up, tell them the project you're working on, and tell them you need a temporary license. And it's a nuisance because you got to call them up every 2-3 months and get it renewed. But they have different grades of licenses that will stop working after 3 months. Not because the licenses that I have, when the license expires, everything that was released, all the software that was released by Altera up to that point, you can use. So I can go backwards in time and I can pick 10.1 Quartus if I want. I can't use anything that past the date of the license, any new IP or any of the Quartus versions. But all the ones that are before my expiration date all continue to work forever, and I can download, and they don't cripple out. Okay. However, that's not to say that there aren't licenses that they can issue that do cripple out, because they have evaluation board licenses that are good for certain time limits.
Yeah.
So just depends on the license you get.
Yeah. So that's the point where I'm currently stuck.
Okay.
Did you have this sort of issue with when you were doing the HPSDR project?
Well, not really, because Phil wrote his own.
Phil never used the tri-speed Mac.
No, he never did.
And on the IQ2,
he wanted it all open source.
And on the IQ2, we used tools that we had full license tools.
Mm-hmm.
So, and that's the thing is, I can build something into a loadable file, put it up on the web, and anybody can load it forever into that box, and it'll work.
Mm-hmm.
But you can't make any changes because you can't recompile anything if you don't have a license. So the executable, as a licensed person, I can make executables to give out to anyone I want, and they work forever. that particular executable, but I can't build new executables without and actually I can build new executables on the tools up to the level of where my license expires. So
Yes.
if we were to pick 20.1 and we had a tool that ran through 2021 and then say it expired in December, we could still use that tool in 2022. We could only use 20.1 tools for however long we wanted. And we could still make executables and they would still be able to be distributed and all that, just as if you have a valid license, except that when 2022.1 comes out, you won't be able to use it.
Right. So the website indicated the rules for the macro IP were very different.
Okay. Well, I'm surprised because we use that same tri-speed Mac in the
Okay.
IQ. So
All right.
let me talk to my rep and see what we can figure out.
All right. Thank you. Appreciate it.
Well, I guess we're completed and open for general discussion, although we are at our hour.
So one question for Nathaniel. If we were to be able to get a university license, would there be a way that you could put a license server up on a server at your university that would serve up the license file?
It is within the realm of possibility.
Okay.
So it's definitely something that I would think is possible, and it's also something I definitely would have to talk to IT about. One mechanism that we do have for, we can't do it for everybody, but certainly for people who are actively developing this, we have some sort of like visiting researcher agreement that you can sign, and then you actually get a Scranton email address and login and all that stuff. And so if you did that, then you'd be able to access our internal system. So that's probably one way to do it, if we couldn't just make it publicly available. So then the people who needed to actively access that license server, we could probably get them through the Scranton.
Because it's a FlexLM license server, so if they could get access to your network,
right?
Which
you'd have
to set up a VPN into.
Right. So the easiest way to do that would be to basically fill out this guest researcher form, and then you'd get a VPN assignment and you'd log in that way.
Okay.
So it's possible.
Okay. Well, I'll keep that in mind and see what we can do, because that's part of the greater deal. I doubt seriously that we're going to be able to get a university license and host it anywhere other than at a university. So because they're probably going to be pretty strict about that.
Yeah. So I think that it would make a lot of sense for us to host that then.
Yeah. And if we could,
you mentioned ARDC before, and I heard them talking on a podcast briefly that they're building an FPGA lab that they're trying to get people access to.
Right, they already have it built.
They've got it built.
At least they already have access to Xilinx tools.
Okay.
Yeah. So, and that was hosted through ORI, Open Research Institute. That they're the ones putting the lab together. So that has a possibility too that it could be hosted there, except they just basically purchased the license. And being a cheap bum like I am, I would rather get a free university one if I could.
Sure.
But we'll see what they'll give us, because I've had attempts in the past to get into the university program, especially when we did the B Radio project, which is a really great academic introductory SDR type of thing. They gave away something like 500 kits that we designed of these boards that plug on to B Micro SDK, and they ran worldwide labs. Aero Electronics did all around the world, giving these. So if you sign up for I think you pay $50 for the seminar and you get the kit for free, or maybe the whole thing was free. I'm not sure, but at any rate, I tried to get it in at the university program at that level with that project, and I got no traction. So they were more interested in getting engineers, getting their product in front of engineers, I think, than in the schools, which is, in my opinion, a mistake. But you know, I don't run Altera, so I don't have much say. Some things I have a good say on, some things I don't have any say on, which is most things. But I think this is different because this is several schools all working on an NSF grant, looking for tools to use their parts. And, you know, part of my pitch is going to be, well, look, you know, Xilinx licenses are online. You want to be left out? I mean, you want us to use your parts or not? You know, help us out here if you're going to help us out. So we'll see what happens. It depends a lot on getting the ear of the right person, you know. And if you can't get to the right person, then you may get nowhere. And if you get to the right person, you may get a lot of action, because I think there's a lot to be gained by the company here. And I mean, realistically, the incremental cost of handing out tools is zero. Okay. So if it's going to be to a good cause and this is why university programs exist at all. So anyway, enough of that. See what we can do. Great progress, Tom, though. That's impressive.
Well, a lot of reading and a lot of YouTube videos.
Yeah. But about the only way. I mean, I learned all this on my own over years, but you're trying to cram all that into, you know, 2 days.
Yeah. So here's the list of talks that I have so far for TAPR DCC. Unfortunately, it looks like we lost Jules. But so I guess we'll have to confirm this with him.
We lost who?
Jules, he had to cut out. He said 7:30.
Oh, okay.
Yeah. So
by the way, this weekend is the Ham Expo. I think Dave, did you mention that? Dave?
Jay mentioned it.
Jay mentioned it. So yes, so there's going to be a myriad of talks. I think they got 90 some talks scheduled for Friday, Saturday, and Sunday.
Wow.
So you got like 5 tracks, I think, going at the same time, which is going to be interesting.
Good news is you have a month to go back and see what you didn't get right off.
Yeah, I think a month or 2 months, something like that, 30 to 60 days. You get to continue.
I'm pretty sure it's 30 days.
Yeah.
Not a lot of time, but at least you don't have to see everything all at once.
Yeah.
That's what they did the first time around, but they've got all the ones from the last QSO Today thing out on their website now, so you can see them anyway.
So the idea is that you can just hop around from room to room and see what's interesting, and
if you wait long enough, you can see it all anyway.
Yeah. But I mean, in real time, when they're being given, when the recordings are being played, you can just pop into one room and say, well, that looks interesting. And I'll wait. I don't care about that. I'm going to pop over here to this other room. And you can just move around anywhere you want throughout the 5 rooms, right? I think that's the way they meant it to be.
Well, they make the schedule available. It's already available. So you can pretty much plan your day and then pick up the ones you miss next 30 days. I have a problem, and that is we have a big public service event on that on Saturday. Oh,
yeah, well. Do you have the bike ride? Is that what it is, or a run?
This is a Big Brother, Big Sister half marathon here in Flagstaff.
Okay.
The bike ride was last Saturday. That's the Marine Corps charity, Toys for Tots. Runs from Flagstaff up to the canyon, 65 miles. And it's an easygoing thing.
Yes, except it's a 7,000 feet. Yeah, I remember in my younger days when I used to run 10Ks, I remember running the Sedona 10K. And that's only 5,000 feet or 5,500 feet, something like that. But compared to running and training and all that at 1,100 feet, and then going up there, whoo, boy, was that a tough run to do.
There's a couple of brothers that call the Extreme Ultra and a couple of other superlatives. up and down Humphreys, which is up to about 12,000, and up and down Eldon a couple of times. And I don't know who can do that. That just sounds ridiculous.
Yeah, Humphreys is the tallest peak in Arizona. It's what, 12,100 or something, and so they probably run up the ski lift trail, right?
Something like that. I don't know. We gave up. They had too many safety violations. We don't support them.
Well,
and besides, it's a commercial outfit.
Well, during the summer, you could take the ski lift up to Mount Agassiz, which is the sister peak, which is about 300 or 400 feet lower. You can hike across the ridge, and then you can hike down. But I could see why they'd have safety violations, because I did that once when I was younger, because they had a hemp fest in Flagstaff. So I would say, oh, let's go up to Humphreys Peak. Well, we hiked up, we rode up to Agassiz, we hiked over to Humphreys, and then we kind of ran down the peak from Humphreys to the ski lodge. Oh my God, it is so steep. I'm just going, like, if I was on skis and I looked down that trail, I would freak out.
Yeah, we have people that actually do that, and I have one of the people I worked with went up to the top, looked down, and they rode the lift back down.
Yes, really. So anyway, we were jumping down, we were running down, jumping from boulder to boulder, and I'm thinking, for what I know now, that was the stupidest thing you could have done. All you had to do is miss one landing, and you'd be bent in half.
Yep.
So anyway. Good luck to them.
So let's see. This is what I have for the potential talks. Does anyone have any comments on these? So I have Scotty, you were there on Thursday. Scotty and Bill, I think, and I think Joe was there on Thursday when we first created this.
Need a microscope to read it.
Let's see, I think I can probably fix that.
Did you have a 50-inch screen, Dave?
It's extremely
I have a
readable.
15-inch screen.
Does this help?
It's high resolution, but yeah, that helps.
So has Deb agreed to give a talk? I'm just going down the list.
Yeah, so one thing to ask would be, how long do people want their talks to be? So you get either a 15-minute slot means you do a 10-minute recording and you answer questions for 5 minutes, and a 30-minute slot means you do a 20-minute recording and you answer questions for 10 minutes.
I'll take the shorter one, the 15-minute slot. I don't think I have a huge amount to say.
Great.
And did you talk to Jules at all, or is he?
I was hoping to get him earlier. So I know that this talk that he has, the one I have here, he's planning on giving one for the American Geophysical Union meeting. So I just use the same title for
Is it the same length?
Roughly. The AGU one is supposed to be a 20-minute. So I guess I should check with him to see if he wants 15 or 30 minutes. Hey, Yeoman, what do you think about all of this? I know you had some thoughts too.
Well, I mean, the only comments that I had was that, we don't want to dominate the conference with hand-size stuff. I mean, if you have enough time and if you have enough slots, then yeah, I don't see any problem with that. Although I guess even for magnetometer project, we have 4 different talks. I don't know if that's.
I mean, it might make sense for all of us to just give 15-minute talks.
Yeah, and I'm saying like Jules' talk is 30-minute long. Is that really necessary, or?
Probably not.
Yeah. So.
And this is, Nathaniel, might be dependent a little bit on what other talks we get, because if we have time, I mean, rather have more ham size stuff than have dead air if we don't get other talks.
Yeah.
But yeah, like Yeoman says, we don't want to over dominate it, but the magnetometer is kind of a good thing to talk about because it's kind of like our up and coming thing. That's the hot thing right now, because there's units deployed. We're getting test results back. Bill's got his RF susceptibility tests done. We're getting, we've got a small circle of experimenters.
Right.
And it's a very magnetic topic.
It is.
Oh.
Well, I mean, if people think that it's good to have like many different topics for magnetometer, I'm totally fine with it. I'm glad to hear that a lot of people are getting more interested in this magnetometer project. So I don't have a problem.
What would be really good is if we could say, okay, here's the 4 tops, or here's 4 or 5 or 6 talks, 15 minutes each on the magnetometer, what you can do with it, how you build it, where you get it, and all that. And then, oh, by the way, TAPR just announced that you can buy one now. So you're going to get maybe a whole lot more experimenters out of that if you could say, go here and buy the boards.
Mm-hmm.
So what, on a side track question, what's the mass production capacity? Like how fast can you roll out the magnetometer product? Like,
well, it turns out that I've got very good quotes from USA manufacturer that's right here in my town. So I would say, barring any parts issues, which that's a big if these days, barring any parts issues, I can roll that out pretty darn fast after after we get an okay on the prototypes, because basically there's going to be no change. So it's just a matter of ordering like 500 boards and then getting enough parts to build 500 of them. And then the question might be, how many actual 3100 daughter cards can we get? I don't know how many P&I has in stock. And when you show up and say, I'd like 250 of them, please, you might find out that they have 25 in stock. You just never know.
Mm.
I mean, it's probably a good idea to warn them that we're looking at production run in September. Because I think we could do, so we got what, we have about 5 weeks, right, until DCC. That's pushing it a little bit to actually have them available. What we could do though is perhaps we could take orders for delivery in a couple weeks after DCC.
Mm-hmm.
That might be feasible.
That would be good.
And I've been, trying to figure out what we can do. I mean, the kit's going to consist of 2 boards and a bag of parts. Okay, because the through-hole parts are going to be soldered, the final parts are going to be soldered on by the user, because the unit that goes in the pipe doesn't need the 40-pin connector, and so it doesn't need to be soldered on. And these through-hole parts are expensive to manufacture, to have someone solder them on, because they have to be done by hand. So the idea is we sell the board to the ham, and then every ham knows how to solder, right? So they just solder these parts on as required. So we're trying to keep that kit of parts under $100, which is 2 boards, the P&I board, and all the extraneous parts that you need. So really, you're going to need that kit. You're going to need 100 feet of shielded cable, and you're going to need whatever kit we come up with for the in the ground section, which is the pipe and the brackets and the bulkhead connector and all that. So there's 3 components to it. But the idea being, our component is just one order, one SKU. You order that, and you get everything you need for both ends.
Mm-hmm.
The electrical part for both ends.
Mm-hmm.
And then you need to get the mechanical part for burying it, and then you need to get the cable. So. And we're thinking really that the mechanical part's going to be separate from the the PC board part, because it's going to be really hard for a user to assemble a PC board with all the SMT parts on it. But the user could relatively easily, I think, take the bill of materials and go to Home Depot and buy a pipe and a cap and a level and, you know, the mechanical pieces. So give them a bill of materials, and if they want to go do that and roll their own, they can do that, or they could buy one from TAPR if we get to the point where we have a kit that they can buy. But that, I think that's the easiest one for them to duplicate without much trouble, because it's all commonly available parts.
Yeah, I agree.
So I'm kind of in favor of working up some enthusiasm for magnetometers. So don't have a problem with, you know, I can see how it could get out of hand, but I don't, you know, an hour and a half of magnetometer talks is not bad in my opinion.
Yeah.
Because we come to HAMSI and we overload it with engineering stuff. So you know, it's,
Sounds great then. Yeah. I have no problem with that.
Yeah.
Nathaniel?
Yes.
Question. I agreed to do a talk for the American Geophysical Union.
Yes. Mm-hmm.
And what I see up here at the top of the schedule you have online right now, proposed HAMSI talks for a TAPR. What is this?
Oh, sorry. Maybe I didn't make that. I'm sorry. I thought that was clear. So there's another, and if you don't want to do this, that's fine. We can find someone else who can do it. But if you want to do it, that would be great too. So there's really no pressure here. But what TAPR is, the Digital Communications Conference is taking place September 17th and 18th, is it? Yes. And this is the conference that is, it's going to be online, and it's specifically for TAPR. It's a TAPR and ARRL conference.
Okay, well, the problem is that particular weekend, we have the most difficult of our public service events. And this is the 100-mile combination bike ride and run from Flagstaff to the Grand Canyon.
Okay.
And we are really, really hard put for people.
Okay.
All of our experienced people have left, either died or moved out of town or whatever, but I'm absolutely not available that weekend.
Okay. Well, there are
Where
two.
this is a video. Could someone show the video and answer questions?
Yeah. Well, I was gonna say there are two options. So one, if you're interested, if you would like to do this, you could make the video and have it pre-recorded, and then we would have other people from the Greek community answer the questions, or we could ask someone else to essentially make a similar sort of talk.
And all these are going to be recorded. So.
Yeah. So all this is pre-recorded.
Well, it'd be good practice for the AGU, but I had planned on having between now and at least November to work on this.
Yes. And that's why, as I said, there's absolutely no pressure whatsoever.
Yeah. Well, I'm just not available that weekend.
Okay.
There is to
so
it.
I will just.
Everybody wants to do everything on the same day. It's really incredible.
Yeah. No, I understand. So we're gonna just mark you out for now.
I'll still work on the one for the AGU.
Okay, that sounds great, Joe. Thank you. So I'll talk to Christina probably tomorrow to coordinate with her and see how she wants to handle this.
And, Nathaniel, Bob Benedict, I'm a bad ham. I can't remember his call sign, even though he lives right next to me, or 9 miles away. Might be he could be convinced to do something, possibly.
Okay.
I mean, you'd have to talk to him. And Scotty, and I know I've talked to you about this before, and Nathaniel, I'm really trying to get Bob Benedict a magnetometer board because we've been able to do some really neat things being so close together with the grape and compare our results, and then run experiments to see if I put attenuators on my antenna, at what point does it fail? we can do the same kind of thing with the magnetometer. And that would help figure out, what is local noise created, from the house, or we're not, neither of us are in completely rural locations, but having two stations so close together with people willing to, he's doing this Python coding, I'm doing stuff in R, we can really compare the signals, which allows us, or could allow us, to get some handle on what's local, what's regional, what's global, and what is just noise. So that's a shameless plug for trying to get Bob Benedict magnetometer.
Yeah, I totally agree. Yeah, that's a good suggestion. Actually, that's what we do as a scientist to compare to the data from other local magnetometer. But here, local is much more local than the scientific instruments that has been funded by NSF or NASA. So
well, and obviously these aren't that quality instrument, but what we can do is compare them, and if their tracking things are somewhat reasonable, and then we can get a handle on what is the local noise from and I think some of the people up in Case must have a magnetometer too. That's not far from us. I mean, it's a little bit farther north.
Nathaniel, I've got one extra one, and I'm going to soon have 5 more extra ones. So
yeah, go ahead, definitely send it to Bob Benedict. Absolutely.
And I ordered I think it was 4 RM3100s to replace my one that went cattywampus allegedly.
So you don't need any of the RM3100s, you just want the boards? Or do you need I've got RM3100s also, so if you need one.
Well, I just spent $150 or no, it wasn't that much. I bought a bunch, so I guess they should go to.
Well, these go with the kits, so I mean you might as well keep them with those. So I'll send you a set. Can I send it to you? That'd be the easiest way.
Yeah,
or if you want to drop me his address and I'll send it to you, wherever you want me to send it. Just let me know.
Yeah, whatever's easiest.
Okay, just let me know where it is you want it.
Okay.
Scotty, Scotty or Dave, I guess Dave Larson's not here anymore. Do these talks absolutely have to be finalized by the 15th?
No, if you're going to get in the proceedings, it has to be done by the 15th.
Okay.
If you're just going to talk, you have a lot more time. And now, while the talk itself isn't due until like the Monday before the conference, which is like the 10th or 11th, whatever it is.
Yeah.
Obviously, we need to know whether we need the abstracts before then, so we can make the schedule up.
Right.
So I don't know what the drop dead date is for that, but it's not, the 15th is not going to be a hard date.
Okay. Yeah, I think it'd be good if I could have another week to get this put together, because I'm going on vacation on Wednesday. So I'm going to be out like Wednesday, Thursday, Friday. And I know, we only had a partial Case Western meeting last Thursday, and I won't be there this Thursday. So Christina will be there, but
she'll be back next week, right?
Yeah, she'll be back this week, but I'll be gone this week. And so I think if I had like another few days to.
And you'll be back the 16th?
Yeah, well, I'll be kind of out of commission on the 16th, but I'll be back on. I should be here at night on the 16th, but
I don't see any problem with you taking the rest of that week to do this.
Okay. Yeah, because I'm just I'm actually having a procedure done on this.
That's still almost a month until the conference. So
yeah,
I mean, if we could get abstracts by then, that would be great.
I think we'll be able to.
Does Steve know anything at all about what you're working on, or because I don't think we've told him?
I haven't talked to him about it, so I should probably drop him an email saying so. So I know you told me to not send this to him just yet.
Well, until it gets a little more, until you've talked to the people and they said, I can do it, or I want to do it.
Right.
I would not send him a list of 20 people, then 10 of them back out, and then it just gets messy. But if this is pretty much once you've talked to all the people and they said, yeah, sure, then it's time to engage him because he'll have more definite ideas on how many talks he wants.
Yes.
And you know, whether he wants to load it up on the Friday morning with this or what he wants to do. He's running it, so
Okay.
like I try to help him but stay kind of out of the way.
Okay. So I need to get in touch with Scotty then. So
Steve, you mean?
I'm sorry, Steve. Yeah. Sorry, I'm starting to lose it here tonight. So okay. Well, it looks like I have some emailing I have to do. So I will work on that and I'll try and get in touch with everybody. So
And then I want to touch base with you on the GPS modules and the EVB modules that John and I, apparently, I don't remember this. John talked to you about some funding for some rework on these. And just I don't want to take time here, but we need to talk or email
okay.
before you go on vacation.
So that would be tomorrow.
Tomorrow, right.
Okay. Yeah. I've got a busy day tomorrow.
Yeah. Well, I mean, this could theoretically wait until you get back, but I'd kind of like to have it done because it's important to get this done. And I'm kind of thinking this would be good because if we do this fast enough, we can get the data back before we actually build the clock module. So if he finds something that's untoward, we have a chance to fix it before we build a whole bunch of boards.
Can we talk about it? Are you? Yeah, we can. So yeah, we can touch base tomorrow, I think.
Yeah, this is just some rework costs, and I don't even know what they are yet. I have to go to the CM and say, but like the GPS, we can't mount it because it's surface mount. It has a bunch of pads underneath it. And it has to be hot air mounted, so you can't just solder it down. So then that's why we're going to take it to the CM and have him do. He's got 10 boards. He's had one built up by a friend of his, but he can't impose upon him to do the other 9 boards.
Right.
So, and then this rework is going to be for the clock. It's going to be interesting because the pinout of the clock is completely different. It's a different size. So what they're going to have to do is they're going to have to take the old oscillator off the board, glue the new one on upside down, and run wires to the pads, which is going to be really ugly because the thing's only 2.5 by or 3.5 by 5 millimeters. Is the size of the oscillator, which is why they're going to do it and I'm not, because it's incredibly fine work. And I'm sure they'll do a great job, but it's beyond the scope of what I really want to tackle myself.
Yeah.
So
do you want to talk about that tonight after this meeting?
Yeah, we can do that.
Okay. Sounds good.
Should only take a couple minutes.
All right.
Going QRT. Good night, all. 73. We'll catch
Thanks,
you the next
Bill.
time.
7-3.
7-3.
Thanks, everybody.
Yeah, I'm gonna bail as well. Thank you for having me. See you. Is there a Thursday thing as well?
Yes, there will be a Thursday one.
Okay.
And no Wednesday one with Kong, right, Nathaniel?
That's right. No Wednesday one with Kong.
And the Thursday one has a different URL.
That's right. Yeah.
Yeah.
It's if you go to hamsci.org and click get involved, it's the one that says Case Western Grape Telecom.
And it's at 10 a.m. Eastern, right?
That's right.
All right.